Okay, in the exercise problem, we are going to study about the first problem. The following graphs represent the current versus the voltage and the voltage versus the current for the 6 conductors A, B, C, D, and E. E and F. Which conductor has the least resistance and which conductor is having the maximum resistance? Say out of the 6 conductors given, we have to calculate which conductor is having the maximum resistance and which conductor is having the minimum resistance. First of all, let us consider the diagram. First of all, we have to calculate the resistance available for each and every conductor. If you are considering this figure A, voltage is taken along the y-axis and current is taken along the x-axis. As we know, resistance R is equal to V by I. See, in this given graph, if you are considering the slope of the figure A is y-intercept divided by x-intercept. Y-intercept is along the y-axis is we are having the voltage. Along the x-axis, I am having the current. So, if I am taking the slope for A, B, and C, the graph A, graph B, and graph C, I can able to calculate the resistance. First of all, I am calculating the resistance for A or A. In order to calculate RA, you drop a perpendicular from the point A to the x-axis. So I can drop the perpendicular to the x-axis and also to the y-axis. So when I am dropping the perpendicular to y-axis, the y-intercept is 0 to 2. So y-intercept is 2 minus 0 divided by, what is the x-intercept? X-intercept is 4 minus 0. So I will be getting 2 divided by 4. 2 by 4 is 1 by 2. 1 by 2 is 0.5 ohm. So resistance of A is 0.5. Similarly, I am calculating the resistance for B. For resistance for B means I am dropping a perpendicular from B to the x-axis. So it is meeting at a point where it is meeting at a point 3. If I am dropping a perpendicular to the y-axis from B, I am getting or I am meeting it at 4. So RB is, what is the value of RB? Y-intercept 4 minus 0 divided by, what is the x-intercept? 3 minus 0. So 3 minus 0. What you can able to get then? 4 divided by 3. 4 by 3 is 1.33 ohm. So resistance of B is 1.33 ohm. Similarly, you calculate the resistance for C. Now you drop a perpendicular from C. When you are dropping a perpendicular from C, it is meeting at a point 2. Similarly, drop a perpendicular to the y-axis, it is meeting at a point 5. So y-intercept is 5 minus 0 by x-intercept is 4 minus 0. So I can get it out as 5 divided by, isn't it, y by x. So I can say it is 5 divided by what? 5 divided by 4. What is that 5 divided by 4 then?
5 divided by 2.
5 divided by 2. Sorry, not by 4. Then 2 minus 0. So I have to get 5 divided by 2. 5 divided by 2 is 2.5 ohm. So I have calculated the value for the resistance values for the conductor A, conductor B, and conductor C. Let it be as it is. Similarly, you have to go for the option B or the graph B. Here also the resistance is given by the formula V by I. But here when I am writing here, I can write like this: y-intercept by x-intercept. Here x-intercept is considered to be V. And y-intercept is considered to be what? Y-intercept is considered to be I. So resistance R is equal to, because y by x means here V by I will be getting you 1 by of slope. Slope is y by x, isn't it? Slope is y by x is, see, let us take like this. See, instead of writing like this, I am taking it like this. See, the resistance is y by x. Resistance is v by I. When I am considering slope, slope is y-intercept by x-intercept. But here in this graph B, y-intercept is I and x-intercept is what? X-intercept is V. I by V is nothing but 1 by resistance. So I can write 1 by resistance is equal to slope. So if you want to calculate the resistance for this given graph B, you calculate 1 by of slope. So what you can able to get 1 by y by x. So in this case, what you can able to get R will be then equal to x divided by y. Then we can write R is equal to x divided by y means you can get it out as v by I. Are you understand? Are you able to understand what I have told? Here if you அதாவது இந்த செகண்ட் கிராஃப்ல நீங்க ஸ்லோப் கால்குலேட் பண்ணீங்கன்னா y by x தான். y by xங்கிறதுக்கு என்ன ஃபார்முலா வருது? I by v ன்னு வருது. ஆனா ரெசிஸ்டன்ஸ்ங்கிறது v by I. அப்ப ரெசிப்ரோக்கல் ஆஃப் ஸ்லோப் கால்குலேட் பண்ணீங்கன்னா தான் உங்களுக்கு ரெசிஸ்டன்ஸ் கிடைக்கும். அதனால தான் நான் மாத்தி போட்டுருக்கிறேன். 1 by of slope is x by y. அப்ப x by y எவ்வளவுன்னு நீங்க கால்குலேட் பண்ணீங்கன்னா உங்களுக்கு v by I கிடைக்கும். I am taking the value for resistance D, conductor D. See, when I am dropping a perpendicular from D, it is meeting at a point 4. When I am dropping a perpendicular to the y-axis, it is meeting at a point D. Here I have to get x by y. So x is 4. What is y? Y-intercept is 2. So RD is equal to 2 ohm. புரிஞ்சுதா? Very clear? Similarly, if you are calculating for RE, drop a perpendicular from E to x-axis, it is meeting at a point 3. For y-axis, it is again meeting at a point 3. For x by y here, 3 divided by 3, it is 1 ohm. Similarly, you calculate RF. What is RF? Drop a perpendicular from F, it is meeting at a point 2 in x-axis and 5 in y-axis. So 2 divided by 5. What is 2 by 5? It is 0.4 ohm. So when you are considering all the resistances for 6 conductors, RC is having maximum resistance. RC is having maximum resistance, which is equal to 2.5 ohm. And RF is having what? RF is having minimum resistance, which is equal to 0.4 ohm. Okay, clear? So I can say RF is having the maximum, RC is having the maximum resistance and RF is having the minimum resistance. புரிஞ்சுதாடா?
Yes, sir.
According to your problem, RE, see this E is extending up to 4 ampere in y-axis. So you change this 3 divided by 4. If it is 3 divided by 4, the resistance available will be 0.75 ohm. See, instead of 4, I have drawn the diagram up to 3. That is the reason why I have marked it as 3 here. But according to your book, the graph is extended up to 4 amperes in y-axis. So you extend it up to 4 amperes. If so, RE is having 4 ampere in y-intercept and 3 ampere in x-intercept. And so, graph இப்படி வரணும் இல்லையா? இங்க இருந்து இப்படி வரணும். So you are able to get the answer as 0.75. புரிஞ்சிட்டல? Okay, now let us go on to problem number 2. So what is this problem number 2? Come on, go through the problem. See, lightning is a very good example of natural current. In typical lightning, there is 10 power 9 joule of energy transfer across the potential difference of 5 into 10 to the power of 7 volt during a time interval of 0.2 seconds. Using this information, estimate the following quantities: total amount of charge transferred between the cloud and the ground, the current in the lightning bolt, and power delivered in 0.2 seconds. Come on, Go through the problem again. Lightning is a very good example of natural current. In typical lightning, there are 10 joules, 10 to the power of 9 joules of energy transfer. So energy is taken to be E, which is equal to 10 to the power of 9 joules of energy. Across the potential difference is represented as V, which is 5 into 10 to the power of 7 volt. During a time interval of t is equal to 0.2 second. What it is asked, using this information, estimate the following quantities. Total amount of charge transferred. You are asked to calculate what is the amount of charge Q. Then the current in the lightning bolt, you are asked to calculate I. Then the power delivered P. In what time? The power delivered in this time of 0.2 seconds. See, we know the formula for energy. The energy is given by the general formula, power into time. Or I can write this power as voltage into current into time. So what is the value of energy? Energy is 10 power 9. See, energy is 10 power 9 joules, isn't it? So I'm writing 10 power 9 is equal to, what is the voltage? It is 5 into 10 to the power of 7. I can calculate the current available, I, multiplied it with the time. Time is 0.2 seconds. So take this to the other side to calculate current. I is equal to 10 power 9 divided by 5 into 0.2 into 10 to the power of 7. 5 into 2 is 10, but 0.1. So 5 into 0.2 is 1. When I am dividing, I can able to get 10 to the power of 2 amperes, or I can write I is equal to 100 amperes as the answer. So I have calculated the current I as 100 amperes. How to calculate the charge? We know that. Okay, we know that the charge Q is equal to I into T. Since the current I is equal to rate of flow of charges, since current I is equal to Q by T, charge Q is equal to I into T. So charge Q equal to, what is the current? That is 10 to the power of 2 into, what is time? Time is also considered to be 0.2. So charge Q is equal to 0.2 into 100. So charge Q is equal to 20 coulomb. So charge has been calculated as 20 coulomb. Then the third one, what is the power? So what is power? Already we know that the power P is equal to V into I. So what is, or I can write like this, power is equal to energy divided by time. Since in a time of 0.2 seconds, what is the power? It is asked. So I am using this formula. Power P is equal to E by T. What is E? E is 10 to the power of 9 divided by 0.2. How I can simplify this? This can be written like this, 10 power 9 divided by 0.2 can be written as 2 into 10 to the power of minus 1. 1 by 2 is 0.5. Take this 10 power minus 1 to the numerator, you can able to get 10 to the power of 10. It is in watts. So power can be written as 5 into 10 to the power of 9 watts. Or 10 power 9 remove pannitona giga. 5 gigawatts is considered to be the value of what? The value of power that is available. Hope you should have understood this. So you can copy it out. So this is the problem number 2. A copper wire of 10 power minus 6 meters square area of cross section carries a current of 2 ampere. If the number of electrons per cubic meter is 8 into 10 to the power of 28, calculate the current density and average drift velocity. Come on, go through the problem again. A copper wire of 10 power minus 6 meters square area of cross section So area of cross section capital A is 10 power minus 6 meters square. Carries the current of, so current capital I is equal to 2 ampere. If the number of electrons per meter cube is number density, small n, is considered to be 8 into 10 to the power of 28 per meter cube. Number of electrons per meter cube. You are asked to calculate the current density J and then the average drift velocity V suffix D. First of all, let us calculate the current density. We know that J is current density. So we can write like this. Current density J is equal to current per unit area. J is equal to I by A. So what is the value of I and what is the value of A? The value of I is 2 divided by, what is the value of A? 10 power minus 6. So taking this to the numerator, you get 2 into 10 to the power of 6. Current density measured in terms of an unit ampere per meter square. So I can write J is equal to 2 into 10 power plus 6 ampere per meter square. This is the value of current density. Okay. Then we have to calculate drift velocity. See, we know the relation between current and drift velocity. We know that current I is equal to N into A into E into V suffix D. As you know, I is the current, N is the number of electrons per unit volume, A is the area, E is the charge of the electron, V suffix D is taken to be drift velocity. See, this equation can be written like this. I divided by A equal to J. Because A can be divided here. N into E into V suffix D. From this relation, I can write V suffix D is equal to J divided by N into E. Am I correct? If I am taking this relation alone, I can write, because J I know already. So I am taking this relation. J is equal to N into E into V suffix D. From this, you calculate the drift velocity V suffix D. It is J divided by N into E. What is the value of J now? 2 into 10 to the power of 6. You substitute 2 into 10 to the power of 6 divided by, what is the value of N? Number of electrons, 8 into 10 to the power of 28 into E, 1.6 into 10 to the power of minus 19. Shall we simplify? See, this 2 and this 8, if you are cancelling, you will get 4. Then here you are having 10 power 28. Here you are having 10 power 6. If these two are cancelled, you can get 10 power 22. Then this 10 power 22 and this 10 power minus 19 get cancelled. You can able to get 10 to the power of 3. Isn't it? Now, this can be written as, in numerator, you are having 1 divided by, here you are having 4 into, here you are having 1.6. I am writing it like this, 16 into 10 to the power of, here I have taken 1 0, 2. So this can be written as 1 divided by 4 into 16 can be written as another 4, then 4. This 10 power 2 taken to numerator 10 power minus 2. Am I correct? See, I am simplifying. Drift velocity V suffix D is equal to 1 by 4 is 0.25 into another 1 by 4, 0.25. Then another 1 by 4, 0.25 into 10 to the power of minus 2. So this can be written as 25 into 25 into 25, multiplied it with 10 to the power of, here minus 2, minus 2, minus 2, minus 6, here over minus 2, minus 8. Multiply 25 into 25 is 625. Again, into 25, into 10 to the power of minus 8. So you can multiply 625 into 25, 5 into 5, 25, 2, 5 into 2, 10, 12, again 1, 30 plus 1, 31. Then 625 into 2, 1250. You just add, you will be getting 5, 2, 6, then 5, then 1. So I can get the answer as 1, 5, 6, 2, 5, into 10 to the power of minus 8 meter per second. Writing it in scientific notation, this drift velocity can be written as 1.5625 into 10 to the power of 1, 2, 3, 4, 10 to the power of minus 4 meter per second. In your book, they have given the answer like this. V suffix d is equal to, taking this decimal to the right hand side, you can write 15.625 into 10 to the power of minus 5 meter per second. This is the answer that we can able to get it for drift velocity. On question number 4, the resistance of a nichrome wire at 0 degree Celsius is 10 ohm. If its temperature coefficient of resistance is 0.004 per degree Celsius, find the resistance at the boiling point of water. Comment on your result. See, the resistance of a nichrome wire at 0 degree Celsius. Then T0 is given. T0, they have considered it out as 10 degree Celsius. I think it is in your book, they have given it out as 20 degree Celsius in your book. So it is T, okay, if it is 20 degree, then also it is T0. So T0 is equal to 10 degree Celsius. Sorry, not 10 degree Celsius. T0 is considered to be in your book, it is given as 20 degree Celsius, which is having the resistance at what? Which is having the resistance R0 as 20 ohm, sorry, as 10 ohms, isn't it? In your book, in your old book, it is given as 0 degree, but in your new book, it was being given as the resistance of the nichrome wire at 20 degree Celsius is 10 ohm. So temperature T0 is 20 degree Celsius, and the resistance at that temperature, temperature is 10 ohm. Its temperature coefficient of resistance alpha is given to be 0.004 per degree Celsius. Find its resistance. Okay, you are asked to calculate the resistance at boiling point of water, that is T. T, it was given to be boiling point of water. What is the boiling point of water? Boiling point of water is nothing but 100 degrees Celsius. So you are asked to calculate the resistance at 100 degrees Celsius or 100. How to calculate? We know the formula RT equal to R0 into 1 plus alpha into T minus T0. We have calculated, we have studied this formula, isn't it? T alpha into T minus T0. So substitute in this formula and get the answer. So instead of RT, I am putting it as R100. Here I have to put R0 to be 10. 1 plus, what is alpha? 0.004. What is T100 minus, what is T0? Sorry, T0 is 20. So I am putting minus 20. Then I am closing the bracket. Simplify. R100 is equal to 10 into 1 plus 0.004. 100 minus 20, it is 80. So R100 is equal to 10 into 1 plus, then you are multiplying 0.04 into 8. So we can say it out as 0.32. Isn't it? 2 digit tally pulli veikano. Mottama 3 digit na innor 0 irukku. So 0.320 varum. I am considering it as 0.32. So I am getting R100 is equal to 10 multiplied with 1.32, which is equal to 13.2 ohms. So the resistance at boiling point of water R100 is equal to 13.2 ohms as its answer. Hope you should have understood. The rod given in the figure is made up of 2 different metals. Both have the square cross section of 3 millimeter side. The resistivity of the first material is 4 into 10 to the power of minus 3 ohm meter, and is 25 centimeter long, while the second material has resistivity 5 into 10 to the power of minus 3 ohm meter and is of 70 centimeter long. What is the resistivity of the rod between its ends? In between, so not the resistivity, what is the resistance of the rod between its ends? Paklam. What it is asked, what it is given again. The rod given in the figure is made up of two L materials. Let us take this as the material 1 and this as the material 2. Both have a square cross section of side. Then I can say side is equal to 3 millimeter and the cross section is considered to be square cross section. Since the cross section is a square cross section, then I can get area of the cross section is equal to side into side. So area of cross section A is equal to 3 into 10 power minus 3 into 3 into 10 power minus 3. I have converted this millimeter into meter. 3 into 10 to the power of minus 3 meter. So area of cross section is 9 into 10 to the power of minus 6 meter square. Then the resistivity of the first material. Resistivity of the first material, I am taking it as rho 1, which is 4 into 10 to the power of minus 3 ohm meter. And its length is L1 is called to be or taken to be 25 centimeter. So 25 into 10 to the power of minus 2 meter. While the second material has a resistivity. So second material is having a resistivity rho 2. And the value of rho 2 is 5 into 10 to the power of minus 3 ohm meter. And the length is L2. How much its length? It is 70 centimeter. 70 into 10 to the power of minus 2 meter. And what is the resistance of the rod? You are asked to calculate the total resistance of this combination, RT. So therefore, you are asked to calculate RT, total resistance of the combination. See, I can say like this, the total resistance is equal to the resistance of the first conductor plus the resistance of the second conductor, because the two conductors are connected in series. That is, the end of the first conductor is joined with the beginning of the second conductor. So it is in series. The end of the first conductor is joined with the beginning of the second conductor. So like this, it is going on, means it is taken to be what? It is taken to be a series combination. Then what is the value of R1 and what is the value of R2? I am writing it here. We know that in general, resistance is given by the formula R is equal to rho into L divided by A. So I can consider R1 is equal to rho into L1 divided by A1 and R2 equal to rho 1 into rho 2 into L2 divided by A2. I can find it out separately and substitute it here, or I can substitute the formula and simplify. Whatever the thing we can do. I'm doing it like this. First of all, I am calculating rho 1. What is rho 1? Rho 1 is 4 into 10 to the power of minus 3 into. What is L1? L1 is 25 into 10 to the power of minus 2 divided by. What is the value of A1? A1 is A is common. So 9 into 10 to the power of minus 6. Similarly, I can calculate what? Similarly, I can calculate for rho 2. That is, rho 2 is 5 into 10 to the power of minus 3. Multiplied it with 70 into 10 to the power of minus 2 whole divided by 9 into 10 to the power of minus 6. Take these two values and substitute it here. Or simply, if you are making a mistake in this calculation, then the whole thing will go wrong. So substitute and do the simplification. Resistance at total resistance is equal to R1. I can take 4 into 10 to the power of minus 3 into 25 into 10 to the power of minus 2 divided by 9 into 10 power minus 6 plus 5 into 10 to the power of minus 3 into 70 into 10 to the power of minus 2 whole divided by 9 into 10 power minus 6. Common common RT equal to See here 10 power minus 3, 10 power minus 2, 10 power minus 5. Here also 10 power minus 5. So I am taking 10 power minus 5 out by here both 9 into 10 power minus 6 can be taken as common. So here 25 into 4 I can get it out as 100 plus. Here 70 plus 5 I will be able to get 350. Am I correct? Okay, am I correct? See, 10 power minus 3, 10 power minus 2, I have taken 10 power minus 5 in both of the cases as common. And here 9 into 10 power minus 6, I have taken it common. So this 10 power minus 5 and this 10 power minus 6 get cancelled. Here I am having 10 power minus 1. This 10 power minus 1 taken to the numerator 10 divided by 9, multiplied it with 350 plus 100, I will be getting 450. So when I am cancelling this, I can able to get 9 5s are 45, 50, 50 into 10, I can get it out as 500. So I can write the total resistance RT is equal to 500 ohms as its answer. Hope you should have understood what I have written here. Okay, so copy it out.